Okay, so in the last chapter in grade 11, you should have gone through, I know my guys, I did do sinusoidal functions. I did tell people, I think with one of my classes, it was, you didn't have to do the test, but you should do the homework because you're gonna need it for grade 12. Did anyone not do sinusoidal functions in grade 11? The ones, those who didn't have me? Okay, so there was two, so it says trig functions, but we're looking at sinusoidal. Sinusoidal means the waves. Okay, so we're introduced to two of them. So we have sine x and cos x. Okay, they're pretty much the same thing. One is just shifted. One is just a shift of the other. Okay, does anyone remember what they look like? Sorry, wrong word. Does anyone remember where they start? So one starts at one part and one starts at the other part. Megan?
Does one start at 1 and one start at 0?
Good, so one starts at 0 and one starts at 1. Which one? Alex? Sine starts at 0, 0. Okay, and then cosine starts at 1. Okay, so sine is always going to start at 0, 0, which in the basic form is called the equation of the axis. But we'll get to that part later. Okay, so we go from 0, and then where does sine go? Where does it go? Can you read it?
Up to 1.
It goes up to 1. So it starts at 0, 0, then it's going to go up to 1, where 90 is. So it goes at 90 and 1. Okay, it goes up to 1. Once it hits that point, it then comes down. So it goes up to 1, and then it's going to come back down to 0 at 180. Okay, after 180, where does it go? Owen?
-1 at 270.
Good, so now it goes down to -1 at 270, and then once it hits the lowest point, it goes up to 0 again at 360. So every 90 degrees, it's kind of a changing direction. So you go up to 90, then it goes down, all the way to -1, and then back up to 0. So that's sine. And that is one cycle. Okay, we're just driving one cycle. This would be continuous. Okay, this would keep going. It's cyclical. Okay, this one keeps going, but we're just drawing one cycle here. Okay, cos does the same thing, except for it starts at 1. Okay, so then it's going to go down to 0, 0, 90, and then continue downwards till it hits -1. And then once it hits its lowest point, which is -1, it then turns and goes upwards, and it goes back up to +1 at 360 degrees. Okay, so that's the parent function. The parent function. And again, it could be continuous both ways. So it could go negative and positive. So if you were to continue it, you can see that they're the same. Okay, one's just shifted 90 degrees to the left. So if you just shifted the sign over 90 degrees, you would have cosine. Okay, so in its very basic form in the parent function, it goes as high as +1 and as low as -1. Okay, that can change once we do like stretches and compressions, but the parent function from high as 1 to -1. Okay, so let's get some terminology here. We have a middle line here. Okay, it's not an asymptote, it's just a middle line because it's the middle where it's halfway between the highest and lowest point. So this is 0 in front of the parent function. So halfway. Does anyone remember what that is called? Simrat? Sorry? Not amplitude, that's something else. We'll get to amplitude in a minute. Owen?
Equation of the axis.
Oh, you guys remember that? Equation of the axis. So it's the middle line. So in short form, I just write EOA, equation of the axis. And that's the middle line. Okay, when you have an equation, the equation of the axis always is your C value. It's always your C value. So if there isn't a C, then it's 0, which is where we are now. Okay, in our equation right now, there's no C value, so it's 0. So our equation of the axis is at 0. If you don't have the equation, you can find out where the equation of the axis is by using a formula. Does anyone remember the formula for the equation of the axis? Tyler?
Maximum plus minimum divided by 2.
Good, so it's your maximum value. So the EOA is your maximum value plus your minimum value divided by 2. So if you think about where we are right now, so it would be 1 plus a negative 1, so 1 minus 1, which is 0, divided by 2, which is 0. Okay, a couple other things. So Simrat mentioned the amplitude. Where is the amplitude?
It's between your equation of the axis and your maximum and minimum values.
Good. So your amplitude goes from your equation of the axis up to the highest point, or from the equation of the axis to your lowest point. It will always be the same thing. So whether you measure it from the equation up to the highest point, or the equation down to the lowest point, it is the same value. This is your amplitude. Yeah, can you let me know, Kiana, if that stops at all? My memory is very low. And in the equation, A is your amplitude. Okay, A is still the same thing as you guys learned in other equations. Okay, what would the A value be in, say, a quadratic? What's the A value? What does it tell you about the graph? That's it? Vertical stretch or compression, right? So it's the same thing, it's still your vertical stretch or compress. So if this was a 2, this gets stretched up to 2, right? We just call it amplitude in this case. So if it was a 2, this would go up to 2. That's a vertical stretch, okay? So same thing, but we can just measure it using amplitude. Okay, your D value, well, actually let's go K. What's K value in any function? Horizontal stretch or compress, okay, that's going this way. Okay, and learning from last year, what is the K affect in a sine or a cosine wave? What does it affect? Remembers this, if I'm stretching it or compressing the wave.
Would it affect the period?
It affects the period, so I'll give you the formula for that, okay? And then we have D. D is shift left or right, always the opposite. And your C value is how much it goes up or down. So that's the equation of the axis, we can move it up or down. Okay, so the whole thing would move up or down. Okay, so I'm gonna erase these. Everyone still copying this? Let's get to something else, so the K value. Okay, so the K value is still your horizontal stretch or compression, but to calculate the K value in the equation, it is 360 degrees divided by your period. So if you want to find your K value, you take 360 degrees and you divide it by your period. Oh, I forgot to do something. I'll do it in a second. Since we don't use degrees, you could do it by 2 pi divided by p. If you were graphing the parent function, guys, you could do the degrees here, but then switch it. So this would be pi over 2. This would be pi. This would be 3 pi over 2. And then this would be 2 pi. Okay, so since we're changing everything from degrees to radian, if I ask you to graph on the test, which I will, make sure that your graph, you can put degrees at the start if you want to, but then convert them after. Make sure your final answer is in radians. Okay, and the last thing I want to talk about is the period. So the period is how long it takes to create or to complete one cycle. So if I was looking at the parent function, how long would it take a sine or cos to complete one cycle? What would it be? Madison? 2 pi or 360 degrees, okay? So our period for both the sine and cosine and its parent function is 360 degrees. So it takes 360 degrees to complete one cycle, and then it would repeat itself. Okay, and if we have a formula for that, and it's almost the same as this one, you just swap these. So the period is 360 degrees divided by your K value, or 2 pi over K. Okay, the way I taught this last year was to follow 4 steps. Okay, so we're gonna graph these. Okay, so what I taught last year was 4 steps. You could graph any one of the equations. Some of you guys might have used the mapping formula last year to graph these, but I like to use my 4-step method. I'm just gonna move this over here. So now we're going to do some graphing. That'd be a good idea, eh? I guess make sure. Okay, let's start with the easy one. Okay, I'm not gonna plot anything yet. Okay, so the first step, the way I like to graph, is we're gonna plot the first point. Okay, so the first point is always what your C and D values are, okay? What's my C value here in this equation? Actually, maybe we'll label this. What's the 2 gonna be? What letter? A, right? So A is in front of the sign. Okay, K would come after in brackets. So that's our A value. And if it's a +3 outside of the brackets, what value is this? Our C value. Okay. So our first point is going to be C, which is 3. And what's our D value? 0. We don't have one, so it's 0. So I'm going to plot this as our first point. And maybe I should use my graph a little bit bigger. Let's split these into twos. Okay, so I'm going to just label my y-axis. Okay, so my first point is going to be at 3 and 0. Sorry. Sorry guys, this is opposite. It's D. Sorry, it's DC, guys correct that. Because your D is your X value, your C is your Y value, so it should be 0 and 3. My apologies. Please make that correction. That's our first step. Second step calculate the period. And then divide by 4. And then okay, how do we calculate the period?
$360
360
divided by K.
divided by K, so it's 360 divided by K. What's our K value here? What number's in front of the X?
1.
1. Okay, so it's a 1 here, not 0. Okay, if you put 0, this won't, you won't get an answer. So it's 1. So our period is 360 degrees. Okay, so we're gonna know that this is gonna end 360 degrees later. And now it says, so that's calculate the period. Now we're gonna take that answer and divide by 4, always by 4. And you get the answer of 90. Mr. McKenzie. Sorry? Yeah, it is. I think that's 20. Where am I? I think it's 2. Let me just check. 1 second. 1 second. And if it doesn't answer, that means he's probably on break. So just like no worries. Okay, so then we're gonna take the answer from number 2 and add it to the first point 4 times. Okay, so we're at 0 degrees here. Okay, so we're gonna add 90 4 times, and each time we're gonna put a dot. Okay, so if I go from 3 and 0, sorry, 0 and 3 degrees, I'm gonna add 90 degrees 4 times. Okay, so I'm gonna go a point at 90, so this is gonna be 90, 180, 270, and 360. Okay, so I'm gonna have a point at 90, a point at 180, so 90 degrees, another 90 degrees, another 90 degrees, and then one more. So by step 3, you should have 5 points. You guys remember this from last year now? For those who had me? Yes? For those who didn't, probably didn't do this. But I'm telling you, this is the easiest way. It's so easy to graph. Instead of doing mapping, we have to do all the calculations. This one becomes super easy. And there's one more step. Last step. Okay, these 5 points are gonna make that wave. If it's sine, we're gonna move second and fourth point. If it's cos, we are gonna move the first, third, and fifth points. I taught two grade 12 classes last year, and I had a bunch of students thank me for this method because they understood it a lot better than the one they learned in grade 11. And at first it's gonna feel weird if this is your first time learning it. Okay, so the fourth one, if it's a sine formula, we're gonna move the second and fourth point. If it's cos, we're gonna move the first, third, and fifth, okay? Do we have sine or cos? Sine, so we're gonna move this point and this point, okay? Based on amplitude. So we're gonna move it based on the amplitude. Okay, so I'm moving this. What's my amplitude? My amplitude is 2. So I'm gonna move this up 2. It's positive 2. So I'm gonna move it up 2. So it goes from 3 to 5. It's a positive 2, so we go up 2. And the fourth point, you go the opposite. So I'm gonna go down 2. And then we can end. And then we have our wave. Okay, and then you can erase these ones after. Erase, erase. We have our wave. Okay, I did make one mistake, or I didn't fix something. What's my last step? Adam?
Convert to radians.
Yeah, make sure this is in radians. So pi over 2, pi, 3 pi over 2, and 2 pi. So make sure that your final answer is in radians for your x values. Unless it's a real life question, which there will be in our next section, then you don't do radians or degrees, it'll be like time. Questions? Yes.
So if it's a cosine graph, would the first one be up and second one down?
Yep. It'll be up, so if it was cosine, this one would go up based on the amplitude. If it's positive, it goes up. If it's negative, it goes down. It'll be the opposite. It's always opposite directions. We'll do one. I'm gonna do another 3, so you guys are like comfortable with this. I'll give you all different situations. So let's go next. 3 cos 2 x minus pi over 2 minus 1. So again, let's label our letters. What's the 3? 3 is A. What's the 2?
Okay.
Okay. Pi over 2, which is 90 degrees, is our D value, and our last one is C. Okay, but this is still going. My memories. Just give you guys a minute to get down a graph. You could use the same one you had. Just put like some values in between. So put like 45 and 35. Just because I'm looking ahead, I know it's gonna go by 45s. So whatever graph you had, you can just add these values in and it will still fit. If you want to do this, if you use the same graph. And by the way, when I'm graphing, that's only one cycle. So if you just keep adding the points, you can get more cycles. Like I divide by 4, so the first one I added 90 4 times, but if I want to do another cycle, I would add another 4. Another cycle, another 4 points, and you can just move them, it would be the same. Okay, so what's my first point? My first point. What's my D and what's my C? Adam?
3 negative 1.
DC.
Or sorry, 90 and 90 degrees are negative 1.
Good, so 90 and negative 1. Make sure, so it's negative in the bracket, so when I remove it, it's positive, right? So it's a positive 90 and negative 1. This one in green, this one. So my first point is going to be negative 1. Sorry, 90 and negative 1. So I'm going to have a point here. Second step, calculate the period. So 360 divided by your K value. What's my K value? 2, right? So 360 divided by 2 is 180 degrees. When I give this on the test, I'm going to ask you to give me the 4 steps. Okay? So remember the second step, calculate the period and then divide by 4. So the period is 180. So period's 180. Now we divide that by 4 and we get what? 45 degrees. Third step. Take the answer from number 2, add the answer from number 2 4 times to the first point. So now we're going to add 45 degrees 4 times. So if 45 plus 90 is 135, plus 45 is 180, plus 45 is 225, plus 45 is 270. Okay, that gives you the 5 points you need to make the weight. Okay, and last step, if it's sine, we move the second and fourth points. If it's cos, we move 1 through 5. What do we have? Sine or cos? Cos, so we're gonna move 1, 3, and 5, and we're moving them based on the amplitude. Okay, what is my amplitude? 3. Positive or negative 3? Positive. So I'm going to go up 3. 1, 2, 3. So this one's going to go up. What do you think is going to happen to my third point? Down 3. Here. And my last one, up. It's always opposite. So up, down, and then up. And then we connect the dots.